In this video, we'll begin our discussion of section 4.4. This is called the undetermined coefficients. It's a superposition approach, so we'll find a solution to the homogeneous case, and then we'll find a particular solution and put them together. We discussed this in section 4.1, that our general solution will be the homogeneous case. So that's our homogeneous solutions, and then it's going to be plus our particular solution. So we're going to have to find the solutions to the homogeneous case and then find a particular solution and then put them together. This method really is a guessing type method. And it only works if you can eyeball, okay, a couple things. Notice that all the coefficients for this diff EQ are all constant, so that's important. And then the right-hand side is a polynomial, so that's going to help out quite a bit because we can try to figure out what the original function would have looked like if I resulted with a polynomial. Okay, first things first, we do the associated homogeneous equation. So that's going to be 2y double prime plus 3y prime minus 2y. And I set it equal to 0. That's the homogeneous thing. I know I have constant coefficients, so that means I can switch to our m's here. This thing is going to factor. All right, this is 2m minus 1 times m plus 2 equals 0. That is m equals 1/2 and m equals -2. So we have this solution y of c. And then just like the section before this, we have c1 e to the 1/2 x plus c2 e to the -2x. Okay, so we're going to hold on to that. We're going to use it in the very end to create our general solution. All right, so you'll do that every single time. This is going to tell us some stuff a little later in our lesson, so be aware that that's going to be important. Now we do our particular solution. So this is how it works. It's going to be kind of tough. You're going to pick things. It's not going to be so bad up front. And then once we start making the right-hand side of this diff EQ worse, there's going to be a lot of problems where you're going to guess, be wrong, and have to redo the whole problem. I do it too as many times as I've done these problems. It happens. So you're going to have to guess and check. And then with reps, you'll get better. And I have a couple techniques I'll show you. Okay, so here's my guess. So I'm going to say my particular solution. Okay, if I'm looking at this right-hand side, okay, it looks like I'm taking derivatives. Well, I am taking derivatives of some function to get that. So I'm going to try, since I still have my y here too, I'm just going to guess ax squared plus bx plus c. I feel like if I take derivatives of that, then I might end up getting back to that. So what we do is we take our guess. Now I know I got to plug into my diff EQ at the top, so I'm going to have to get up to my second derivative. First derivative is 2ax plus b. And then luckily this one is pretty straightforward. These derivatives are going to be the worst part. And then 2a for our double. And then I usually like to set it up like this. I'll go 2yp double prime. And I'll go ahead and just multiply it by 2 for a. And then I just kind of piece it together here. So 3p, I'm pulling it from up here. That's where I'm getting the numbers. 3p of that will be 6ax plus 3b. And then we're supposed to minus 2y. So I'm going to minus 2 from the original. So I get minus 2ax squared minus 2bx minus 2c. Now I have everything in order. So all I got to do is just add down. So writing my expression. Right, putting those together, okay, I say I have a negative 2ax squared. Then I'm going to add my x's together, so that's 6a minus 2b times x. And then all my constants together are going to be 4a plus 3b minus 2c. That's just a constant. So I know that's what I get when I plug in. So what I'm going to do is match each one of these, like this negative 2a needs to be 14. This 6a minus 2b has to be the -4. And then the last thing, that this 4a plus 3b minus 2c has to be a -11. So I'm going to create a system of equations from that. So negative 2a equals 14. 6a minus 2b is going to be a -4. And then 4a plus 3b minus 2c that is our constant, which equals -11. If it wasn't up there, we'd put a 0. So there's my system. Now, I encourage you to maybe use a calculator for these systems. They get pretty nasty. Um, and that's where I still try to do these by hand. That's just how I work. And doing that by hand, that's where I make my mistakes. So use a calculator. If you need help, look up how to solve a system of equations on a calculator. If you need help finding a video, let me know. So these are what these values pop out as. So forgive me, I'll plan a little better with this stuff, but I'm going to move some things around here and put that up here. Forgive me. I know you're probably out of room. Uh, I have it pre-planned, but I didn't do so well on making that happen. So I'm going to plug in now those values. So I got -7x squared minus 19x minus 37. So that's my particular solution. And then I know that my general solution will be y sub c times plus y sub p. So general solution is going to be c1 e to the 1/2 x, that was from above, plus c2 e to the -2x, and then minus 7x squared minus 19x minus 37. By the theory that we looked at in 4.1, I know that this is a general solution to the original diffie-q. So we use the homogeneous case and we use this method to create a general solution. We looked at this in 4.1 towards the end. All right, so that's the method. Is you take an educated guess here, you run it through your diffie-q, and then you match your coefficients. Now, the hard part of this section, two things will be this, the guess, unless it's straightforward, and then your system is going to be where you're going to probably mess up. So find ways, use your calculator to come up with that. We're going to do another example in this video. All right, that might be let's finish this problem actually. We have to do this. So we have some initial conditions. Forgive me, I'll do better on the rest of this video with the spacing. I have it pre-worked out, so I think my brain was just on a roll. Okay, so I know I'm going to need y prime, because if the initial condition said y and y prime, so I'm going to need that y prime. So I'm going to go ahead and do that. I get 1/2 c1e to the 1/2 x minus 2c2e to the -2fx. I'm just taking derivatives. -14x minus 19. All right, so I get y of 0 equals 0. That's going to come out as a 0 equals c1 plus c2 minus 37. And then y prime of 0, if I plug that in, I get 0 equals 1/2 c1 minus 2 c2 minus 19. All right, there's our system. If we solve that you could use a calculator, use it by hand, however you want to do it. I get c1 to be 186 over 5 and c2 to be -1/5. So I have a particular solution to my IVP. 186 over 5 e to the 1/2 x. It doesn't have to be pretty, right? Minus 1/5 e to the minus 2x minus 7x squared minus 19x minus 37. So there is my solution to the IVP. Okay, so we had general solution, there's that. I really encourage you for this kind of stuff, like I said, to use a calculator or use a computer. I would maybe get used to the calculator, that way you can take it in on test and solve systems pretty quick. You don't want to waste your test time doing these algebraic systems. I would rather you just actually finish the problem there. All right, we're going to do one more problem in this video just to kind of piece things together a little bit more. So here's our next one. So first things first, they tell us to solve. I notice that these are all constant coefficients. So I can grab a homogeneous solution. So I'm going to try to write smaller here so I can make sure I fit my whole problem. So the complementary homogeneous solution will be, or equation would be 4y prime double prime minus 4y prime minus 3y. And it's going to be set equal to 0. So this is, if I were to solve 4m squared minus 4m minus 3. Okay, this thing does factor. It's 2m minus 3 times 2m plus 1. So that gives me, I have my m's from that. I have m equals 3 over 2. and m equals negative 1/2. So y c equals, okay, I got c1 e to the 3/2 x plus c2 e to the negative 1/2 x. So I have that solution. We'll use that later at the end. Now we got to come up with a guess. So I see this cosine. Now, if I'm thinking about cosine, you might be tempted to say, oh, it's a cosine 2x. But the thing about cosine and sines are that when you take derivatives of cosines and sines, they turn into each other. So my guess, I'm going to need to make it a little bit more than just that. I'm going to do an a cosine. I'm going to leave the 2x because when I take derivatives, those 2x's just stay the same. But I need to make sure I have a sine as well, just in case maybe it started with sine or maybe with both and they ended up adding together. Now, this is the painful part. We got to take derivatives. All right, so right kind of small, we got to fit these in. First derivative is going to be negative 2a sine 2x, chain rule, plus 2b cosine 2x. Okay, I'm going to need the second derivative as well. So I'm just going to keep going. I'm going to get negative 4a cosine 2x minus 4b sine 2x. Right, I'm going to build the equation that I have up there just to kind of try to help out. So 4p, 4 times y double prime is going to be negative 16a cosine of 2x minus 16b sine of 2x. Okay, I also need a 4y single prime, negative 4. So I get 8a sine 2x minus 8b cosine 2x. And then one last thing, it says minus 3y. So I'm going to multiply the original by negative 3. Right, and then now, since I wrote it out that way, let me pay attention to room. All right, we have 4y double prime of p minus 4y prime of p minus 3y. Right, that's my diffeq. So now I'm going to add, and it's just these three here. That's why I do it that way. So we can add all our cosines up. So cosines, I'm going to have negative 16a. Well, actually, here, just highlight them. I'm going to have this one, and that one. So you can see that we have negative 16a, and a 3 makes a negative 19a minus 8b, and that is times the cosine 2x. And then the other one will be these 3. All right, and that's going to be 8a, oops, wrong color. 8a minus 19b sine 2x. All right, so we have that. And then now we have coefficients to set them equal to. So here's our system, negative 19a minus 8b. That must be equal to 1 from above. And then 8a minus 19b is equal to 0 because in our answer, we're looking up here, right? I have a 1 in front of the cosine, but there's a 0 in front of the sine. So that's why we have this system here. So use your calculator or do it by hand. You're going to get a is equal to, it's not pretty, negative 19 over 425. And then b will be negative 8 over 425. So get to those however you'd like. If you'd like to solve by hand, that's up to you. Why particular solution? Now I have these negative 19, 425 cosine of 2x minus 8 over 425 of sine 2x, right? And then we can write our final general answer. There was no initial condition for this, so we'll be done here. I'm going to get c1e to the 3/2 x plus c2 e to the negative 1/2 x. And then I'm going to cheat here and duplicate, but that's also there at the end. I'm going to move this minus so it's more obvious that I'm subtracting. So there is our general solution. We still have c's, that's why it's our general. If we had an IVP, we could solve for c1 and c2. So This method up front, if you know what the guess is, I think it's pretty straightforward. I think it feels like problem 5 of our test where you guys had to plug in and this thing in. They gave you a solution to solve for A, right? But now you're going to have A's, B's, C's, D's, stuff like that. These systems can build up pretty fast. So please, begging you to find a computer, find something that will help you solve a system. Learn how to do that. Like I said, if you need some help, I can direct you to a video or make you a video or meet with you to help you out.